Intelligent measurement of power frequency in induced electric field strength based on convolution neural network feature recognition. First, aiming at the problem of large measurement error in existing electric field intensity measurement methods. An intelligent measurement method of power frequency induced electric field intensity based on convolution neural network feature recognition is proposed. According to the working principle of power devices in power environments, the mathematical model of power frequency in induced electric field is established. The power frequency induction electric field intensity signal is collected by the intelligent chemical frequency induction electric field intensity measuring device. The convolution neural network is used to extract and recognize the characteristics of the power frequency induced electric field intensity signal. Through facial matching, intelligent measurements results of power frequency induced electric field intensity are obtained. The test results show that the average electric field intensity measurement error of the proposed method is reduced by 1.24 Newton per C, which solves the problem of the large measurement error. Next, I'll make some introductions. With the continuous development of power system, more and more transmission lines, the system becomes more and more complex and huge, and the accuracy and the reliability of line parameters are also increasingly strict in power system calculation. Accurate line parameters are the basis of power system calculation, such as power flow calculation, fault analysis, network loss calculation, and relay protection setting calculation. The measurement of power system line parameters have become an indispensable process before the new transmission line is put into operation. Moreover, the commonly known transmission line parameters are measured at the initial stage of the line construction, and these parameters will change more and or less due to the climate, temperate environment, geography, and other factors after being put into operation. Therefore, it is necessary to measure the line parameters that have been put into operation. Power frequency refers to the abbreviation of power grid's working frequency, which refers to the frequency of AC power in the power grid. All generators, transmission and distribution equipment and users in the same power grid use AC power of this frequency. The electric field intensity in some areas of power frequency electric field around high voltage substations, transmission lines, and other equipment exceeds the allowable value of 5 kilometer volts per meters in nation standards. With the continuous improvement of the voltage level of transmission lines, the environment problems caused by power frequency electric fields has become increasingly prominent, which has become one of the main factors restricting the construction of ultra-high voltage transmission projects in China. The timely and effective measurement of electric field is indispensable means to actively face and solve this new threat. Electric field intensity is one of the important indicators of power frequency in that electric field, which is physical quantity used to express the strength and the direction of electric field. The direction of the electric field strength at the point in the electric field can be determined by the electric field direction of the electric field force applied at the point where the electric charge is tested. The electric field strength can be determined by the ratio of the force on the test charge to the charge at the test point. Electric field intensity measurement refers to the measurement of electric field intensity at the receiving site to obtain various propagation data and parameters for correct design of wireless circuits. The measurement of electric field intensity is also an important work in solving electromagnetic compatibility problems. Among the existing methods for measuring power frequency in induced electric field strength, the more mature research achieves include reference proposed an electric field intensity sensor that can be used for unmanned aerial vehicles to solve the technical difficulties of large range field intensity and wireless data transmission and meet the test requirements of ultra-high voltage substations. Take the peeler porcelain bottle as the test object. Carry out the laboratory measurement of the field strength distribution at different voltage levels and different positions. In reference to the measurement method of electric field intensity based on the explicit sensitivity matrix of three-dimensional electromagnetic response is studied by using three-dimensional finite wall method of electric field coupling potential and the direct solution technology. First, the finite volume method is used to discretize the electric field mixed potential equations. The algebraic equations corresponding to the forward modeling of moving source electromagnetic field are established. And the interpolation operator and the projection operator are determined. The projection operator is used to calculate the electromagnetic response of multi-emitters according to the block model and the conductivity distribution characters of the abnormal body. The electric field intensity is calculated by using the decorative vector of the projection operator and the scattering current element. However, the traditional electric field strength measurement methods mentioned above have obvious measurement strength error problem, which is mainly due to the inaccurate exercise of electric field signal characteristics. Therefore, conclusional neural network feature recognition technology is introduced. Facial recognition refers to the extraction of special information of things are phenomenal. And the convolutional neural network facial recognition technology applies convolutional neural network to multiply iterations on the basis of traditional facial recognition technology to improve the accuracy of facial recognition. Convolutional neural network is a feed-forward neural network whose artificial neurons can respond to the surrounding units within a part of converge. Generally, the basic structure of convolutional neural network includes two layers. One is the facial extraction layer, and the input of each neuron is connected with the local acceptance domain of the previous layer, and the local features are extracted. The convolutional neural network feature recognition technology is applied to the optimization design of intelligent measure method of power frequency, includes electric field strength, in order to improve the intelligent measurement accuracy of power frequency, induce electric field strength. Design of intelligent measurement method for power frequency includes electric field strength. First is establishing the mathematical model of power frequency induced electric field. The second step, the installation of intelligent measuring equipment for power frequency, include induced electric field strength, and the third step, the intelligent acquisition of power frequency induced electric field strength signal. Fourth, is establishment of convolutional neural network. The fifth step is extraction and identification of electric field strength signal characteristics. And the last, we need to realize the intelligent measurement of power frequency and thus electrical field intensity. Experimental and the last is the experimental exercise of measurement accuracy test. For the purpose of testing the field strength measurement accuracy of the intelligent measurement method of power frequency induced electric field strength based on convolutional neural network feature recognition. The measurement accuracy test experiment is designed by means of comparative experiments, and whether the optimized design method achieves the expected effective is completed. The first step is the first one is configuration of power frequency industrial electric field environments. The power grid of a city is selected as the research of environment for the experiment. The voltage level of the power grid can be divided into three parts: 5 kilometer voltage, 220 kilometer voltage, and 10 kilometer voltage. In the power grid environment, there is one 500 kilometer voltage substation with a main transformer capacity of 2 multiply 1500 MVA substations with a total main transformer capacity of 5,470 MVA, and the substation with a main transformer capacity of 305 3,587 MVA. Through the parameter setting, ensure that all power elements in the grid are at the same working frequency. According to the operation of each power element in the grid, the configuration result of power frequency in induction electric field environment is obtained, as shown in the picture. A is referred to the 500 kV electric field environments, and B is the 220 kV electric field environments, and C is the 10 kV electric field environment. Structure and the structural parameters of input convolution neural network is below. Because of the intelligent measurement method of power frequency, induced electric field strength optimized and design use the convolution neural network feature recognition method. It is necessary to set the structure and the operation parameters of the convolution neural network. Now, the most important is that a feature map can be obtained by traversing a convolution check with the feature map, and the number of feature maps can be obtained by the number of convolution calls in a convolution layer. And the training member of batch samples is the amount of data contained in each batch, and the learning rate is crucial to the training process of DCAN. If the set learning rate is too large, it is to cause the shock of network recognition rates, which is make it difficult for the network to converge to the minimal points. On the contrary, if the set rate is too small, you will need too many iterations in the training and spend a lot of time. Nailing power frequency induced electric field stream measure points. Randomly select multiply measuring points in the configuration power frequency induced electric field environment and install the designed intelligent measurement equipment in the electric field environment. The specific layout of the measuring points is shown in Figure 8. And after completing the correction of the power frequency sensing, electric field intensity measurement equipment and the program, the measure is first made in the 500 kV electric field environment. Meanwhile, the electric equipment and the measurement equipment in the electric field environment get the visual intelligent measure results of the electric strength through the operation of the convolution neural network feature identification technology, as shown in the below. Next, I will make a conclusion. The difficult of electric field intensity measurement is that the probe is placed in the field to be measured, which is easy to cause distortion due to electrostatic induction. In addition, the follow signal processing is difficult due to the impedance, temperate drift, and other factors. Through the application of convolution neural network feature recognition technology, the intelligent and accurate measurement of electric field strength is realized, providing reference data for the setting and management of power components, electric fields, and other parameters. And thank you for listening.